in our production process, we've got, we left off thinking about the physical relationship between resources or inputs and the actual output we're making. So I brought up the hamburgers. We were at the restaurant. This is my glory days of, this is my grill, right? It's approximately, what, 8 foot? No, this isn't quite 8 foot. 7 foot by 3 foot grill top, right? There's a fixed amount of surface area on this grill. And we thought about changing some of the inputs, the variable inputs, which ultimately ends up being linked to variable cost and fixed cost. So as I want to produce more hamburgers, I need more people, more of our variable resource. And as I added a person in, we looked at the additional hamburgers each additional person made. And that was a distinction between marginal product and total product. And so we're going to expand on that today. I gave you a picture thinking about the units of labor, 1, 2, 3, 4, 5 people, and the quantity of hamburgers. And I said, well, what do you think it looks like? Does it look like A, B, or C? And we came up with C, thinking that eventually, as I add more and more workers, that it starts to look like C, that the amount of hamburgers that each additional person cranks out falls. We start talking about the party next weekend. We start losing track. There's congestion issues. As we start to work around this fixed grill top, we're not as productive as we were. Those extra people end up lowering productivity. Now, what we didn't show was that the actual total product function can be a combination of all three of these things. We talked about it, but we didn't graph it. So that's where I want to pick up today and think about what the total product function looks like. So on the horizontal axis, we'll measure labor, just like we did. Our units of an input, and we're just picking off one of them, labor. And we'll look at the quantity of output, hamburgers, physical quantities, no dollars, right? No dollar sign up here. This is physical quantity of output, physical quantity of input, the actual production process. What that curve looks like is that possibly early on, 2 people can make more together than what each person individually can do. So if I can make 100 hamburgers all by myself, maybe when I add another person, together we can do more than 200. Maybe we can do 220. Why? Because of specialization. I patty the burgers, and he watches the grill. You know, we can specialize in the activities of the production process and possibly have increasing returns to our labor, which is what graph A is showing. And so it's possible that we have A, but eventually, as I add the 3rd person, the 4th person, we kind of quickly deduce that that benefit of specialization is going to wear off, and we're going to fall into the C function, the diminishing returns. And so our total product function would look something like that if that's our story. It's going to be going up, but then it's going to be going down and over. Kind of an S-shaped curve. Because check it out, 0 labor means 0 hamburgers. I got to have people to make them. So we start down at the origin. And for the first couple of workers, maybe, 1 and 2, oops, 1 and 2, I have increasing returns. Notice how this part of the function looks like A. But that eventually wears off and diminishing returns kicks in. So we have this, there's some point along here that's kind of an what in math class we call an inflection point. It's increasing at an increasing rate, and then all of a sudden it turns into decreasing at, or increasing at a decreasing rate. It's increasing the whole time, which makes sense. More people, more hamburgers. We don't get to the point where hamburger production falls off. It's an increasing function, but we believe more in this thing here kicking in, that it's going to be increasing at a decreasing rate. So that gives us the shape of the total product function or curve. The total product of labor, shorthand here, TP subscript L, the total product labor looks like this. All right, so that's where we're at graphically. If that's a bit foggy for you, we're going to put on our schedule goggles next. So we got, I think I started you off with equation goggles. What was that equation again? Total cost can be partitioned into two types of costs. What kind? TVC and TFC. Now, Brian, you bring up a great point there. I, on the board, often do this, TC and TVC plus TFC. But the only reason I do that is to keep class moving along. What I'd prefer to do if I had enough time is I would write total variable cost. And this is total cost is equal to total variable cost plus total fixed cost. That's what I want you guys to do when you're looking at the equation. That's what I want you guys to do when you look at QH. It's the quantity of hamburgers. Don't take that shortcut in your brain or verbally as you're speaking. Don't do that shortcut. Take the time to say the words all the way. Yes, it's true that TVC is shorter to say than total variable cost. But I want to train you differently so that as you're looking at the textbook, as you're looking at a homework problem, as you're looking at whatever, you look at this and your brain sends a signal to your quiet mind that you're not speaking and it says total variable cost. That's going to help you learn this material better because we're always thinking, we use these acronyms all the time, but it's just because we need to keep things moving along and hopefully we know it. But when you verbalize it, say it out. Okay, so there's our equation. We had that marginal cost equation too. We handled some equations. Let's look at a schedule of numbers to get what the real deal might look like. What's confusing in terms of cost is that we sometimes think, well, how do we get increasing cost when everything costs the same? So I might start you off with a little question. How does the marginal cost curve slope up at and slope up? Well, let me just leave it at slope up. How does the marginal cost curve slope up when it seems like marginal costs are constant? So for example, if we're in the hamburger business again, I've got burger and bun. We keep a real simple hamburger. Well, we can break down per bun cost. Each bun cost me $1. Each burger cost me $2. I've got $3 into materials. And so it's like, oh, well, each burger I produce, if I now go back to measuring the quantity of hamburgers on the horizontal axis and think about cost, so I'm back to this graph, bear in mind, it's like $3, $3, $3, $3, right? The first hamburger, the second hamburger, the third hamburger, how much did the first one cost me? Well, it was $3. The second one cost me $3, $3, $3. Well, that would tend to lead you to think that the marginal cost curve looks like this. Same thing with hiring people. Well, I can have as many people as I want for $10 an hour. Marginal costs are constant. Sometimes we use this assumption in class. You maybe remember seeing that on some of your homework or something where we've got a constant cost. But what I showed you last time was that the marginal cost curve is J-shaped and upward sloping. This is what we believe it to be looking like. that every hamburger, each additional hamburger, continues to increase in terms of cost. That's a weird thing that economists are tackling here that's maybe different than the accountants again. Why is that happening? All right. Well, it's going to be closely tied into diminishing marginal product. So, let's take a look. I'm trying to capture this on, the reason I'm saying constrained, if some of you guys are wondering this, is we're trying to catch a little video so you guys can have something to look at later too. All right. I'm going to create a schedule of numbers that has a lot of columns. So leave yourself enough space. Don't write too big. Let's see, what do I got here? 4, 8. I got about 9 columns of numbers we're going to do. So we're going to spend a little time trying to figure this out. All right, so on the column to the left, we're going to measure labor, units of labor. And we're going to look at 0 workers, and then 1 person, 2 people, 3 people, 4 people, 5 people. And next we'll look at the quantity of hamburgers that are being produced at those different combinations of labor. With 0 people, I get 0 hamburgers. 1 person gets me 100 hamburgers. 2 people gets me 220. There's that increasing returns, maybe due to specialization. But the 3rd person only adds another 100. So production ramps up to 320. The 4th person gets us up to 400. And now with 5 people, we can crank out 460 hamburgers. All right, so our first column I want to do is the marginal product of labor. Now we talked about this, but I didn't write it down in terms of a formula. So we'll start by adding our formula here. It is the change in hamburgers that an extra person gives me. So it's a ratio, it's the change in hamburgers, how many more hamburgers do I get from a change in the units of labor? All right, so it's undefined for 0 because we don't even have any people. But now we've got the first person bringing on 100 hamburgers. The second person gives me 120 more. The 3rd person, starting from this point to this point, adds another 100. What does the 4th person bring to my operation? 80. All right, so as you start to look at this, you'll do this in your homework problems too. We're going from 320 to 400. It's really the difference between this one to this one. That last person gives me 60. Those are the marginal products that each person adds. The production is falling. The law of diminishing marginal product is kicking in. That's that diminishing part of our function we looked at graphically. All right, questions on that? Now, the other one I want to put up here, just because people do it and we need to be aware of it, but it's actually kind of stinks. For decision making, it stinks. And that is the average product of labor. How much on average do I get out of my workforce? The average product of labor is very close in terms of its formula, but it is just the quantity, no triangle. Take the quantity you're making, divide it on average by the number of people that it took to make that quantity. So again, 0 is undefined. 1 person making 100 gives me an average product of 100 per person. 220 hamburgers being produced gives me an average of 110 per person. 320 units gives me an average of 106.67, 106 and 2/3 of a hamburger. 400 divided by 4, we're back to an average of 100. And then finally, 460 hamburgers being made by 5 people means that the average person is kicking out 92. All right, here's why averages suck for decision making. Many people, many managers, many businesses will take a look at this number and say, gosh, our company's growing and we're on average we're putting out 92 and I need to ramp up production. If I hire another person, I'll get 92 more hamburgers and our problem will be solved. But is that going to happen? No. Because the last person hired actually only contributed 60 hamburgers to the production process. Yes, on average, they were doing 92. But the decision to hire an extra person is done at the margin. And the law of diminishing marginal product tells me that they're not even going to be doing 60. They're going to be doing something less than 60 because we've got that congestion issue and the lack of productivity for those extra workers. So that's why economists stick to these marginal things that we're having to memorize throughout the whole semester. Look at the incremental impact on small changes. All right, so that's the average product. I wanted to put this up here just so you kind of see how there's a big difference between looking at the 4th person between the average of all 4. All right. Questions or comments on that? Okay, now we get into some money. I want to look at the total cost of labor. What is my labor bill at my company? What is my labor bill? So I'm going to throw in a couple more assumptions just to add some reality here. Let's suppose that the wage per hour is $10 an hour. And we're going to look at a shift for the restaurant of a 10-hour shift. And so if we hire people, we're just going to kind of say we're stuck to paying them a 10-hour shift at $10. Which means one person working for me for one shift cost me $100. So now we're finally getting to some price tags on these things. 2 people working for me, what is my total cost of labor? 200. We're going to go up by 100 each time. So go ahead and fill in the table. 3 people runs me $300, 4 people $400, 5 people $500. All right, so this part here represents a variable cost. You might want to add that in here, right? Because there's a direct correlation between the number of units I get after changing this variable. So this is one of the components of our total variable cost. Let's just add a fixed cost column. Now, what's true about fixed cost as I crank out more hamburgers? What happens to my total fixed costs? They stay what? The same. That's how we defined them. They are independent of changes in this column over here. It doesn't matter how many hamburgers we kick out, we still have the rent for the building. The landlord doesn't care if we make 100 hamburgers or 460. It's a fixed cost. And here's the next key thing that'll help you out on some homework and exam problems, is that at 0, we have 0 labor cost. If I don't make any hamburgers, I didn't hire anybody, I have 0 variable cost, but I still got to pay the rent. So this will help you start tables like this in your homework or exams. this is a key part here, let's circle that one, that at a quantity of 0, you still have your fixed cost. All right, so if these are our only costs, our total cost then is the sum of the two. So we've got our total variable costs associated with labor, total fixed cost is the remainder, and we simply add them up. At 0 quantity, I still have fixed cost even though I don't have variable. And at, oh, I forgot to fill this in here. Total fixed cost, this is the other easy part. It's fixed at every quantity we produce. It's 100 all the way down the schedule. And then we're simply adding them. 100 plus 100 is 2 for total. We ramp up to 3. We ramp up to 4, 5, and finally 6. Okay. Now, the formula I gave you for marginal cost the other day was the change in total cost derived from an additional unit of production, a change in quantity. So what I want to look at here is how costs are changing as I add labor. So what is the change in total cost at each one of these increments as we've got them presented? And so the change is undefined here at 0. It just is what it is. But from here, we went from $100 to 200. We went up by 100. From 200 to 300, we went up by 100. Well, guess what we're doing? We're filling in 100 all the way down using this schedule of numbers. Which brings me back to where we started, that it seems like our costs would be constant the more hamburgers I produce. The change in total cost is going up by the amount of people I'm hiring, is what's driving this result. But that's not what's going on in terms of a per hamburger cost at the margin. The marginal cost, our final column here, is the change in total cost from an additional unit of production. We're narrowing that down to a single unit. Sometimes we don't have sufficient data to go from 1 hamburger to 2 hamburgers to 3 hamburgers to 4 hamburgers, which is exactly what's going on with this problem. I jumped from 0 to 100 to 220 to 320. Right? There's a whole bunch of hamburgers in between that we don't have data on. And so this is how we handle that. Look at the change in total cost over that range from the change in quantity. All right, so what is the marginal cost of the first hamburger? What does that number equal? Change in total cost, I got all the information here. What is it? 1. So it's $1. My total cost goes up by 100. My quantity changes, by the way, the change here, look at this. This is the marginal product of labor. Right? So this really is the change in quantity from those extra units of labor, the marginal product. So we could almost sneak in here, change in quantity is the marginal product of labor. And so, like you said, we've got $100 divided by 100 hamburgers gives me $1 per unit. Each hamburger's running me $1. What is the marginal cost of the second group? Not the second hamburger, bear in mind, because the second hamburger is actually up here. So this is like the cost of the 110th hamburger. We're dropping down to this range, over this production range, but I want to do it on a per unit basis. what is the marginal cost over this range of production after I hire the second worker? What are my numbers? What's my total cost? Change in total cost? 100 divided by 120. Yep, not the total, but the change. That extra guy that I hired brought in 120 hamburgers. And so what we get here, 100 divided by 120, is 84 cents. So effectively, these hamburgers are cheaper than these hamburgers because I'm exploiting the specialization thing. I patty the burgers, you watch the fryer, right? Or you watch the grill, and you toast the buns and I'll butter them or whatever. We've specialized our production and we're getting increasing returns. This is translating into a cost savings. But we've already said that's going to soon evaporate away, that increasing returns. Now when we jump down to the next production combination, what are we back up to? Back up to $1. And as I jump into the next production range, we've got $100 is the change in cost by hiring the fourth person. But the change in output was just 80. And so each burger is running me $1.25 over that production range. And then finally, I hire another person and he drives up my cost $100, but the actual product that he adds to my production process is only 60. So effectively, the cost of those additional burgers that he helped make was $1.67. 100 divided by 60 is $1.67. And now we start to see what we meant by increasing cost. Right there is a key thing for economics class. A lot of times a manager or the accountant will then look at average costs, which I didn't even calculate here. But if I take the total cost of 400 and divide it by 320, I could come up with my average cost per burger. But we're going to run into the exact same problem we did with average product and marginal product. It's misleading. Because the actual cost of an additional burger, if we're already making 460 hamburgers, the 461st hamburger is going to be something greater than $1.67. And if you look at the average cost over this range, I guess we could just go ahead and do this. Take 600, somebody pull out a calculator, take $600 and divide it by 460. I'm just averaging that full $600 total cost over all the units I'm producing, 460. What does that equal? $1.30, right? So it's like, oh, the manager says, oh, well, geez, $1.30, maybe we should have a sale and drop our price to $1.40. We're still making 10 cents per hamburger. Well, no, you're not, because those extra hamburgers that you're selling are actually costing you much more than that. It's not your average cost, it's your marginal cost that you got to pay attention to. So what is driving the result here? If I was to ask you on the test, which I likely will do in some way, shape, or form, why do costs increase with production at the margin? What's driving that result? What is driving that result? Why are these numbers climbing after we get to this point, I guess? $1.25, $1.67. Costs are rising at the margin. What's driving that result? I've hit you with a lot of information and a lot of numbers, but there's something very important driving that result. it might help to look at the formula. I know that sounds crazy that you guys might start to come to a point in your life where you're looking to a formula for an answer. Hopefully we'll get you there. Is it the numerator, the 100? Is that what's driving the result? No, because it's staying the same. What's changing is the denominator. What's that? The MPL, the marginal product of labor. So what gives us increasing cost is diminishing marginal product. The fact that this number is going down is what makes these numbers go up. There's a direct relationship between the law of diminishing marginal product and what we also call the law of increasing cost. The reason why that cost curve is upward sloping. So this helps show that, where that result comes from. And that's why the law of diminishing marginal product is absolutely one of the top 3 econ principles of all time. I haven't ever been brave enough to order these, but this is a biggie. This is right up at the top that changes the way you think about things. The law of diminishing marginal product. We also use the word the law of diminishing returns. This is a little more formal, I think, thinking about marginal product, but we say the law of diminishing returns, same thing. And not sure if I gave this to you already, but as long as we're doing this, let's do it again. As you add, since it's such a biggie, as you add more and more of a variable resource, as you add more and more of a variable resource, like our cooks, I'm going to put parentheses, the labor of cooks. As you add more and more of a variable resource to at least one fixed resource, that is our capital grill top, so our grill top was fixed. That's what caused the congestion, and that's what caused the potential for people to lose productivity. We didn't have an equally balanced approach of giving more grill space to each person. Then this might start to go away. So this is an important part of this. As you add more and more of a variable resource to at least one fixed resource, the product, which in our case is hamburgers, the total product, or the product of those marginal people, the product of each additional variable resource eventually diminishes or falls. This whole definition is strictly physical in nature. No dollars. No dollar signs. That's why we keep it separate from what we derived here. But this one leads us to the law of increasing cost. So the law of increasing cost comes to us from the law of diminishing marginal product. So the law of diminishing marginal product causes marginal cost to be increasing. This is, let's put in parentheses here, our upward slope, the upward sloping marginal cost And then if you remember, there's a connection between marginal cost and supply. What was it? They're the same, right? Marginal cost curve was the supply curve. We're going to do a little more on that later. But our upward sloping supply curve comes to us from this principle also. So we have an upward sloping marginal cost, which is what we really need to know for this chapter, but I'm going to foreshadow a little bit here. Supply curve is marginal cost in competition. The supply curve is the marginal cost curve. That's the thing we've been drawing upward sloping the whole semester so far. All right, questions on that? Let me do one quick little graph since we got the numbers right here to let that J shape kind of reveal itself. So when we draw the cost curves, we're drawing not labor here, but hamburgers, the quantity of output, just like we did in chapter 3 when we did supply and demand. We've got the quantity of a good, and we've got dollars being measured on the vertical axis. We used to put price here, but now we're being a little more generic because we're going to overlap the concepts of price and cost. So let's just be more generic and say that it's a dollar sign. And if we look at our hamburgers and go 100, 200, 300, 400, 500, just kind of equally space out these hash marks. And then graph it out. At 100 hamburgers, the marginal cost was $1. So if we go, let's see, let's go 1, 2, $1, $2. The marginal cost at 100 units was $1. At 220 units was our next jump up. We had 84 cents. 0.84 is somewhere over here. At our next level, which was 320, we were back up to $1. Our next increment up was what, 400. At 400, we had a $1.25. And then we ramped up to 460, and we were at a $1.67. At 460. Now, your graphs might not be perfect, but the reason I wanted you to do this is you really start to see the escalation of those costs quickly due to diminishing returns. If you do graph it out, and mine's even a little sloppy, granted, there's your J shape, and then those costs start to go really up, increasing at an increasing rate. It looks like that function A I had on the board, right? So those costs are going up fast. That is the law of increasing cost. Now, any questions on that? Let me let you guys catch up. What was the average cost we did that I had somebody pull out a calculator? Was that at the 460 level? Was it? Okay. So at 460, what was it? $1.30 something? $1.30. All right, so check this out. So at 460, at $1.30, which is a little bit higher than my, oh, I didn't put this here. This is my $1.25. $1.30 something at 460, that is 1 point. on the average total cost curve. I'm not drawing the curve in, but that's 1 point on the average total cost curve. 1 point on the average total cost. If we were to carefully draw this out with more numbers than what I have on that schedule, because it gets a little goofy because we have these jumps in quantity. But if you had enough, you'd get that picture we did before. Remember the bowl shaped? So I want to put that up here. Maybe this time let's put a generic marginal cost curve, since that's where we just left off. This time just do it kind of generically. J-shaped, bottoms out somewhere. Does anybody remember what happened between the average and the marginal? What the relationship was? They look like a bowl. Where did they intersect? This would be definitely worth an extra credit point. I don't expect any of you to remember this. Hallie?
Does that intersect at towards the end of the new, or the old marginal cost and the new total?
No, but I think you're talking about how they converge on each other,
Yeah.
and that's right. But where does the marginal cost curve intersect the average total cost curve? Kate?
At the minimum.
At the minimum. All right, good. Now, did you have to look back in your notes?
Yeah.
All right. But I appreciate resourcefulness, so that's still an extra credit point, even though it wasn't off the top of your head. Have that off the top of your head for the next exam. That's an important point. So when we draw that, it's bowl-shaped, and it cuts through the minimum point. So when you draw it, do it like that. And I like to put a big fat dot there, right where they intersect, kind of as a reminder that that's the minimum spot. So this is what's going on here. Back to this graph. The marginal hamburger cost me $1.67. The average cost me $1.30. And so each additional burger that I make starts pulling up the average, but we never get it pulled up all the way. If you guys get a 4.0 this semester, your overall GPA is not going to jump to 4.0, right? It's going to come up a little bit. That's what's going on here. There's my 4.0. Here's my overall GPA. It pulls it up slowly. Then add the other curve. Like Hallie said, be careful as you're coming down. It comes down and hits the minimum point. But then as you start to climb, have that gap narrow. Because what is the difference between the average total cost and average variable cost? What is that vertical height? For another extra credit point, Kate's excluded. Logan gets it?
The fixed cost.
The fixed cost. The average fixed cost. Just want to be a little more careful. The sum of the averages equals, so that vertical height there, we don't need to draw that curve because the information's already there. That vertical height is the average fixed cost. At this unit, Q1, which maybe equals 100 units or something. Maybe it's 1,000, just to make sure we're off of the numbers. So at 1,000 units, the average fixed cost is that amount. The average total cost is that amount. In fact, let's wrap with that, because this will get you on the homework. You really got to have this understanding. If I currently produce 1,000 units, what's my average cost per unit? Graphically, go up to that function, because it conveys average total cost information. Hang a left, and that is the average total cost, whatever this number is. If it's $45, that's the average total cost of producing 1,000 units on average. The variable cost associated with producing 1,000 units, I go up to the average variable cost, I hang a left, and that is the average variable cost of producing 1,000 units. And then, of course, the econ kingpin is the old marginal cost for decisions. Because if I'm currently producing 1,000, the real question of the day is should I produce a little less or a little more tomorrow? That's the decision that we make in econ class. That's the decision at the margin. The only cost relevant to that decision to change the status quo is the marginal cost. And the cost of the 1,000th unit was something much higher than the average of all the previous ones. Maybe that was $65. That is the marginal cost of the 1,000th. Not all 1,000, the 1,000th. That one unit cost me $65. All right, we'll see you Friday.